Hi guys, after discussing categorical data previously, let's now discuss continuous data. Continuous data is never written out exactly. Instead, it is given only to a certain degree of accuracy. For example, you describe your height exactly. Can you describe your height exactly? Well, maybe up to the nearest centimeter, even in millimeters. But still, that is not 100% accurate because maybe it is 180 centimeter. But who can say it is not 180.1 centimeter? Or if you agree to that, maybe it is a tad higher at 180.11 or a tad lower at 180.09 centimeter. Unfortunately, our ability to measure accurately is limited. So continuous data represents such measurements that are correct, but only up to a certain degree. Similarly, if we measure speeds, we give them in miles per hour, but 30 miles per hour may mean 30.01 or 30.001 or 29.99 miles per hour. Similarly, weights cannot be measured with 100% accuracy and represent continuous data. Let's now move towards presenting continuous data. Suppose we have a data on heights of children in a class given to 1 decimal place of accuracy in centimeters. A simple presentation can be to put it all in a table of any dimension. Note the data is unordered. For example, we choose a table of 5 rows and 4 columns. But that doesn't mean you can't choose any other dimensionality, that is, different number of rows and columns. But can we produce a frequency distribution of continuous data like we did for discrete numbers? Yes, we can. Remember we plotted frequency distribution of discrete or categorical data earlier? So let's transform the continuous data into a bunch of discrete categories or classes. Because if we do that, then we can repeat the same process as we did for categorical data, right? So, for example, in this case, we create groups of 5 centimeters of length. So, since the smallest data point in the heights is 120, we start our lowest category from 119.5. Because 119.5 is the smallest number that can be rounded off to become 120. But the first group ends below 124.5 because 124.5 rounds off to 125, which is the beginning of the next category. So the next group, accordingly, begins at 124.5 and goes on for another 5 centimeters. Similarly, the remaining groups are made of intervals of 5 centimeters. So here we have got a frequency distribution now because we know each group and we also know their corresponding frequencies of occurrences. So we have the frequency distribution now, just like we had for categorical data. So here's the frequency distribution of this continuous data, which has now been grouped into 5 categories or bins of data. Bin is another word for calling category. Note this kind of graph, which is created after grouping continuous data into bins or categories, is called a histogram, not a bar chart. There are some differences from the bar chart as well. Note there are no gaps along the x-axis, unlike the bar chart where we could create arbitrary gaps because the distance didn't matter. But in this case, there are no gaps because the boundaries of these bins are adjacent to each other. Where one boundary finishes, the next boundary begins. However, you can force the gap if you prefer, only if you feel it makes visual sense. But if you're wondering why these boundaries are not the same as what we created on the last slide, if you're staring at the bottom of the x-axis, the boundary values look slightly different from the last slide. It is because we used Microsoft Excel to create this histogram. And the Microsoft Excel just looked at the raw data and created its own boundaries as it suited fit. So since we create boundaries ourselves, we can narrow or widen the groups as we see fit as well. But narrowing it too much will leave only one value per bin. I hope you can imagine that. For instance, if we say, okay, that the bin width has to be so narrow, that not more than one value can occur, then every value's frequency will become 1. Okay, and that will not really show you any trends. Thus, how you convert continuous data into categories impacts accuracy of the conclusion you draw. But with a sensible bin width, we can see a trend. For example, in this case, we can see that the middle range is the most common. So, to recap, categorical data is collected into classes, intervals, groups, or categories. Both discrete and continuous data sets can be transformed into categorical data through binning. Frequency distribution can be listed either as tables or bar charts or histograms for the continuous data that has been transformed into categorical data. And yeah, I just said that point, that continuous data can be converted into categorical data, whereas the raw data loses accuracy after conversion. For example, the information for each individual data element is not presented in the final chart or the frequency distribution because the data has been grouped into various categories, and it's the frequency of the groups that we present to eventually show the trend. So that concludes the video on continuous data, and we shall see you in the next one.